In the previous class, we have seen the different problems on polar plots. So the next thing comes into the picture here. It is one of the very important concept. This concept is based on polar plot, and Nyquist has given some of the concept regarding the stability. This is called as Nyquist criterion. I will write Nyquist criterion. The next part of the problem is a different thing. We will be analyzing the stability of plots using Nyquist criterion. So, by using Nyquist criterion, we will be assessing whether the system is stable or not. You have seen in the many problems, some points will be there on real axis, some points will be there on imaginary axis. That means the plot is crossing imaginary axis or real axis. You have located the magnitude there and you will be trying to solve. That is only a part of the problem. Let us see what is the concept of stability according to the Nyquist criterion. Before going to the Nyquist criterion, let us analyze the closed loop transfer function C of S divided by R of S will be, this is a closed loop transfer function, G of S divided by 1 plus G of S into H of S. So we want the values of S. How to get the values of S? Numerator, you cannot obtain the values of S directly. You have to solve something. What you will be solving? You will be solving this denominator part. So if you take characteristic equation, that is 1 plus G of S H of S equal to 0, then you will get G of S H of S equal to minus 1 plus J0. So this is the characteristic function value. So if I consider only G of S H of S, G of S H of S, there are some terms on the numerator, some terms on the denominator. You have solved S plus 1, 10 divided by S plus 1, some terms in numerator, some terms in denominator, S square divided by something like that. So according to the mathematical concept of stability, for the stable system, the zeros must lie on negative part, or the zeros must be negative or complex conjugates. So what are the zeros here? The numerator factors are corresponding to zeros, denominator factors corresponding to poles. So if I consider constant, the numerator terms are S plus Z1, S plus Z2, S plus Z3, etc. So if I consider S plus Z1, so here Z1 must be negative. So S plus Z1 is equal to 0, S is equal to minus Z1. That means the zeros should be negative or complex conjugates. What exactly this means is, in other words, if I plot this should be on left hand side of the S-plane. If it is on left hand side of the S-plane, the system is stable. Otherwise the system is unstable, that's all. If it is on imaginary axis or if it is on right hand side of the S-plane, the system is unstable. Similarly, denominator factors S plus P1, S plus P2. If you solve this, you will get this as F of S. F of S will be K into S plus Z1, S plus Z2, etc. Similarly, S to the power of n, S plus P1, S plus P2, etc. If F of S is equal to 0, then you will get zeros of F of S. If F of S is equal to infinity, infinity means 1 by 0. Say for example, I will write this, F of S is equal to some terms. If F of S is equal to 0, this is 0 means you will get numerator terms. So numerator terms is S plus Z1, S plus Z2. If F of S is equal to infinity, infinity means it is 1 by 0. 1 by 0 means you will get denominator terms. So that means poles of F of S. So here what are zeros of F of S? It will be numerator functions. minus z1 minus z2 etc. Poles of f of s minus p1 minus p2 etc. So this is what the poles and zeros concept, very important. For this you have to solve first the characteristic equation. After that you will get all these things. So 0 means 0 by 0, poles means 1 by 0. So this is like 0 by 0, poles means 1 by 0. This you have to know. After getting these things, the stability concept states it should be on left hand side of the S plane. Negative real part means it should be on left hand side of the S plane. After this, Nyquist has developed some of the contours. How he analyzed the contour is, this is one of the contour. So this is S plane, this j omega sigma minus j omega. Nyquist has analyzed some of the contours. What he has done basically is, he has calculated whether there is any poles on right hand side or not. Because if there is any poles on right hand side, it is making the system unstable. Otherwise, if there is any poles on imaginary axis, then it is making the system unstable. That's why the journey started from here. That means wherever the system tends to become unstable, I will catch hold. So first my journey starts from 0, I will go up to infinity. I will search entire imaginary axis whether there is any poles or not. I will go up to infinity. This is omega is equal to 0, this is omega is equal to infinity. And then I will search entire right half of the S plane. This is S plane. I will search entire right half of the S plane. I will be searching whole right plane, and the radius of this will be r e to the power of j theta, r tends to infinity. So this is the limit. I will be going up to infinity, I will search whether there is any poles or not. So this is just like this. I have given some money to some people and he is not available. I need immediately money. What I will do is, I will try to catch hold him. Like that, I will be searching for him. Here also, that poles are the culprit. Poles on right hand side is the culprit and poles on imaginary axis is the culprit. I will be searching. How I will be searching? I will be searching in this contour. These contours are called as Nyquist contour. And my journey is not over. Still there is a minus infinity, because if it is lies on negative imaginary axis also, the system tends to become unstable. And I will come to 0. So this is minus 0. So this is segment 1, this is segment 2, and this is segment 3. So there are 3 segments. So here the journey will be starting. This is O, A, B, C. This is the case where there is no pole at origin. This is a case where no pole at origin. There is another case. If there is a pole at origin, what I need to do? This is sigma j omega minus sigma minus j omega. If there is a pole at origin, there is a culprit here. Pole at origin, culprit. What I need to do? I won't go there because it is like a devil. What I will take is, I will start nearer to him, but I will not go up to that pole. And again I will search entire positive imaginary axis. This I will call it as O, A. Here omega is equal to 0, omega is equal to infinity. I will go up to infinity. Again I will search entire right half of S plane with a radius. What is the radius? Same thing. R e to the power of j theta, r tends to infinity. I will be searching entire right half of the S plane, then negative I will be reaching minus infinity to, again I will be coming with minus 0, omega is equal to minus 0, and I will take a bypass here. Since there is a pole, I will take a bypass. So this is first segment OA, second segment ABC, third segment CD, and fourth segment it is DEO. And the fourth segment radius is infinitesimally small, that will be equal to small r e to the power of j theta, where r tends to 0. Again a small value. This is a case pole at origin. Most of the cases this will be there. Then another case is there. What does that case means? Again sigma j omega. This is all S plane cases. Then here there is a pole, but there is a complex pole at imaginary axis. Complex poles will be obtained in terms of pairs, plus or minus, you know already that. So plus will be there, minus will be there. Pole at origin as well as complex poles. So what I will do is same exercise. I will start here. This is 0. I will go here. Wherever there is a pole on complex side, I will bypass it. Then again I will go up to infinite. Then I will search entire right half of the S plane. Then again I will go here. This radius will be r e to the power of j theta, r tends to infinity. And this is a first segment OA. This is second segment AB. And this radius will be r e to the power of j theta, where r will be a. What is this distance? This distance will be a. Then this is second segment. Segments will be more in this case. This is third segment. Then after that infinite. Infinite, there is again a pole. I will bypass it. This is fourth segment D, E, and F, fifth segment. Sorry, this is first segment, second segment, third segment, fourth segment. This is fifth segment. This is sixth segment. Then again, I will go up to minus 0. This is seventh segment. And this is the last segment, segment 8. The radius will be r e to the power of j theta, r tends to 0. For this, r e to the power of j theta, r tends to minus a. So this is plus a, this is minus a. This is a case of complex pole. Since there are number of segments, there are 7 segments, you need to solve 7 segments, time consuming. We will convert this to a this and we will solve. So more so ever, there are only 2 cases. One is no pole at origin and pole at origin. What he has done is, he has searched the entire path in which the system will be unstable. Here, left hand side, no searching, because if there is any poles or zeros there, the system will be stable. But if it is on right hand side, the system will be unstable. With this, Nyquist has given the Nyquist criterion. What is a Nyquist criterion? Nyquist criterion states that for a stable system, n circumference about critical point minus 1 plus j0 will be equal to poles of f of s. So this means n minus 1 plus j0 is equal to z RHS minus p RHS. So this is a Nyquist stability concept. According to the mathematical stability, z RHS must be 0, always 0. Why? In order to get closed loop stability condition. Keeping this into mind, Nyquist has plotted P or Hs. So these contours are called as Nyquist contours. Nyquist contours. So this is a Nyquist contour. He has searched wherever the system tends to become unstable. So encirclements about the critical point -1 plus J0 will be equal to P or Hs. This is a Nyquist criterion. This is a Nyquist criterion. So we will solve problem on Nyquist criterion, and let us see what is the procedure to plot Nyquist criterion. Let us see the procedure to solve Nyquist plot. As usual, the first thing is you have to consider open loop transfer function. After considering the open loop transfer function, find out the poles and zeros. So you have to find out f of s. After finding poles and zeros, first if you find poles and zeros, locate the poles and zeros in S plane and find Nyquist plot in S plane. Nyquist plot in S plane. Here, if there is any zeros or poles exist, you will be knowing by seeing this plot, this is one case and this is another case. If pole is at origin, this case. If there is no pole at origin, this case. Only two things. Next, number 4. After this, why we have done this? This is, we are calculating whether there is any pole on right hand side of the system or not. If there is any pole on right hand side of the system tends to become unstable. So first we will search. So here what we will do is, we will be searching if there is any pole on right hand side or not. Even in imaginary axis, the same thing. The contradictory portions we solved here. Nyquist solved contradictory portion and we find out P or Hs. Then mapping. What is mapping? Mapping is the transformation of Nyquist plot in S plane to Nyquist plot in G of S, H of S plane. Nyquist plot in S plane to Nyquist plot in G of S, H of S plane. That means we will be solving each segments that will be explained in the problem. After that, Nyquist plot in G of S, H of S plane. So you will be solving Nyquist plot in G of S, H of S plane. So after conversion of this, you will be getting the values, you will be plotting that values. So here you will be finding encirclements about the critical point or not. If Nyquist plot in G of S, H of S plane is crossing negative real axis, then locate -1 plus J0. If it is crossing negative real axis, then locate -1 plus J0. After locating this, find out what is omega p, then find what is magnitude of the plot. If magnitude of the plot is less than 1, -1 plus J0 will be, according to that concept, gain margin and phase margin. Where will be the -1 plus J0? So this part, this is for stable system. This is a critical point, -1 plus J0. Where is -1 plus J0 here? Here it is located after the plot. Similarly, if magnitude is greater than 1, -1 plus J0 is before the plot. By seeing the location of -1 plus J0, find out n minus 1 plus j0 here. Then after that, use Nyquist criterion. What is Nyquist criterion? N minus 1 plus j0 is equal to z or hs minus p or hs. What is z or hs? Z or hs will be 0 always to get closed loop stability. And then n minus 1 plus j0 is equal to minus p or hs. So LHS is equal to RHS. If both are equal, the system is stable. If LHS is not equal to RHS, the system is unstable. So this is the procedure of Nyquist plot. First problem we will be explaining all these things in detail. Thank you.